I'm not going to be spending the same amount of time on all of these fallacies. Obviously, in more modern systems, the network topology in terms of the number of servers, where they're located, the databases, all that kind of stuff is more volatile today than it was, let's say, 10, 15 years ago. And in a cloud environment, obviously, the physical machines are almost non-existent and things are moving around all the time. I don't want to spend too much time talking about the physical aspects. I want to talk about programming models that can run into issues in an environment where the machines are more volatile. So specifically talking about a pattern that was formalized in Microsoft WCF called callback contracts. Who's used callback contracts before? Okay, some of you. For those of you that haven't, it's a very simple idea where, in essence, there's full duplex communication between a client and a server. What that means is that the server is holding onto the address of the client in order to push stuff back to them, usually asynchronously. So it's a great way of implementing events or notifications. But even if you haven't used it, people are doing these types of patterns on top of REST fairly frequently these days. What's the problem with the model where the server's holding onto the address of a client? It's what happens if the client's no longer there. Now, obviously, if the client is wireless, then it's more likely that there's going to be some type of networking issue. But in any type of environment, anytime you're holding onto an address, when the topology changes, that machine might not be there. Now, the issue is, what does that do to the system when you can no longer access something that you expect is there? That's often the place where you're going to start getting hit by, at the very least, timeout exceptions. Now, understand that if the type of invocation that you're doing is a synchronous and blocking invocation back to one of these clients, then that can end up tying up a thread on your server for a very long time. An HTTP timeout, as we know, is by default 30 seconds. So that actually may be even an attack vector to hurt the availability of your system, of a client coming on, registering for certain actions to be notified about, and then just abruptly turning itself off. So if it can, in essence, fill the pool of clients that need to be notified with a bunch of clients that aren't there, that can waste a lot of server resources while they're waiting for those HTTP calls to time out. So be very careful, not only in terms of hard coding or configuring where things are on the network. Anytime you're doing this type of full duplex type of model where you're holding onto the address of the other party, understand that that can have an impact on the runtime performance of your system. Now, in terms of solutions, there are no magical solutions, or all of the magical ones are actually a whole lot more risky than they might appear. Obvious ones, don't hard code IP addresses. Now, none of you are ever going to do this intentionally, but tell me if this has ever happened to you, where you wrote some quick and dirty demo code, never to be used in production, and then it ended up in production. Raise your hand if that's happened to you. All right, I've got about 80% of the room. All right. This is where that comes from. Not because any of you intended that code to be production quality code, but it happened anyway. All right. So that's one of the things that should be on your list of, at some point in time, looping back, grepping your source code for IP addresses that might be lingering in there. IP addresses, domain names, etc. So all kind of hard-coded stuff. Obviously, don't do that if you can avoid it, but check to see that it didn't happen behind the scenes anyway. Consider using some more resilient protocols, multicast type of communications where you're not necessarily calling one specific address, but you're willing to talk to a range of addresses. Security guys hate this, usually try to lock this down. But sometimes it is worthwhile. We won't get into that right now. Discovery mechanisms where the system starts up and just sort of, usually via some sort of multicast mechanism, talks to other things on the network and says, this is who I am and what I can do, who are you and what can you do, and the system sort of configures itself magically at runtime. Developers love building stuff like this. It's really cool and fun. It usually works great on your machine. It might even work well on a small number of machines that are all running at the same time, but they can be fairly fragile. And one of the worst case scenarios is the system stops working, an admin reboots something, and the discovery doesn't work. And then the system's not working, the admin's kind of looking at it, kind of saying, And sometimes that fixes it. Just kind of a good whack on the side, reboot everything all over again, and now it works. But as you've had that experience yourself with certain appliances around the home, sometimes you whack it and it doesn't fix itself. That's the problem with these types of really cool magic types of infrastructure. When they don't work, they're totally opaque. So if you're going down a path like this right now, I suggest you stop, go back up to regular type of config, and there's often the problem we just have more config that we know what to do with. And that's going to lead us to our next fallacy I'm going to talk about in just a second. But one of the things to keep in mind around topology changes, will the system be able to preserve its response times, its performance characteristics, when the topology changes? So this could be as simple, as I said before, as a client becoming unavailable. It could be a server going offline or rebooting or something like that. Usually when we do performance testing on our system, we kind of bring everything up all at the same time, make sure that everything's working perfectly, and then run the performance test. Not to say don't do that, but because that can flush out a whole lot of problems. But be aware that that is non-reflective of the types of production incidents that will occur around topology changes. So if you thought it's difficult to make a system perform well when all the servers are running, imagine how much harder it is when a given server is rebooting or something like that. So those are the kinds of things I recommend you test for that stuff earlier, all right? As a general rule of thumb, if you're on a project, I suggest somewhere at around the 30% mark, you should have built out enough of the architecture and enough functionality to be able to run your first performance tests. Performance test early. The thing that, I don't want to say that I hate it the most because it has driven me a lot of business over the years, is that people will send me an email or call me up and say, Udi, we heard that you can help us out. We have this really big complex system. It needs to go live like in 2 weeks. We have these performance problems. We've tried everything. We don't know what to do. Usually at that point in time, it's kind of too late. You might be wondering, oh, okay, so what do you tell them to do? There is one general practice that I tend to tell people that, if you're very close to your deadline, you have severe performance problems, and you can't really rewrite the system at that point. The one solution that I found tends to work relatively well in a sort of a deterministic fashion. Tell them, get the biggest, most expensive server that you can, deploy everything on it. Your database server, your web servers, your integrations, everything goes on the big gigantic box. And of course there's the pushback of, no, we can't, it's not gonna, we can't get a budget. We were supposed to build a distributed system. That ship sailed, all right? You've ended up building a monolithic system. Now you need a monolithic deployment. Get rid of all of the unnecessary network calls, deploy everything to one big gigantic box. That will give you the fastest, most meaningful performance improvement. And in some ways, it's often the cheapest because developer time is fairly expensive. When you add up 5, 6, 7 developers working for 6 months, 8 months trying to redesign and rejig all the performance problems, that might end up being more expensive than just buying a $250,000 box. All right, and you can get a lot of memory and some really great I/O for $250,000. So consider that path, especially if you're right up hard against a deadline. But in general, you can try to avert those types of disasters by performance testing early. All right. So don't wait with performance testing. You should start doing it. Good rule of thumb, 30% of the project, and then repeatedly thereafter. It should be something that you do on a regular basis. It gives you feedback onto where did we screw up in our architecture.